Okay, my name is Mntwana. I'm an original black man. The caveman. Let me close my door here. My apologies. Now let's get started. So we have a question right here. They say integrate. So let's get into it. So the first question, what I'm gonna approach, look how I'm gonna approach, right? First, I'll take this to the top. So this is gonna become integral. So this is gonna come to the top because look, 1 over cos of anything equal to sec 1 over cos. So this instead of writing 1 over, because here's like 1 over, the same integral of sec, but there's a square, write my square, then I have 3x, but then we have a square root 1 minus, and then, no, it's not 1 minus, tan, and then square 3x minus 1, and then we have a dx. So we have a rule, a little rules, right? Especially when it comes to that part right here. Whenever you have, let's say you have integral, let me write here at the back a little. You have an integral. Let's call this, let's say f of x or u. Let's call f of x. So if this f of x and then square minus a, because this can be any number, it could be 3 square. Did I say 1 here? Okay, let's say 16 now. 1 is going to be more easy. Let's say 16. So if this, okay, this one could be a square, means 16 means 4 square. So we could say a square. So this is right here, same as that. Means this is going to be 4 squared. So when you differentiate f of x, it gives you f prime of x. Then we can say, because if I differentiate tan of whatever we have, it's going to give us sec squared. See? So then this rule, because that's why I say this is always is similar to that. Because if I differentiate tan, I get sec squared. That's why I say when I differentiate f of x, I get what? F prime. Because it's like f squared. So if I take f differentiate, I get f prime. Can you see here? Only. So if there's a sign here, means I cannot use this rule. Because let's say if you differentiate tan, you don't get sign. So you don't use that rule. So for now, yes, we can. So we say then, so oh, where's my pen now? Sorry, my phone. Then pen here, the pen is better. So then we say, according to 1 over 2 f of x. So you can say f of x, simple like that. And they say integral, you say square root. And then after that, you write exact. Which is going to be what? F of x. And minus, but I must write square here. Fx squared minus a squared. So you just simply take this and write that. So you write fx over 2 equal to that. And then here you say minus, and then you do the same thing. You say a, but for now you must take this value here. You write a, and then you over 2 is the form. Okay? And they say ln, and then write exactly here. F of x minus a square, and then u minus u plus u plus f of x, and then you put absorb, and then u plus. So this you just memorize. It's simple. But if it's plus, if it's minus here, it's become minus. If it's plus here must be plus. But the rest of the stuff remain the same. So for that case now we know. Okay, well then I can plug in all my values. I'm going to say, well, integral. So for now, what is f prime? F prime is this. F of x is this. Minus. So instead of saying this is going to be 4 squared. So I'm not going to rewrite again. And I can say simply equal 1 over 2. And then f of x, what is f of x? Our f of x for this case is tan. So I'm going to say tan 3x. Okay. And then we're going to say square root. Then we say square root, and then f of x. What is f of x? Tan square. Now this one's not right. Tan square 3x. Tan square 3x. And then let me write my square. Well, tan square 3x minus a. A means 4 squared because a squared equals 16. Okay, and then minus a. What is a? A means this number, which is 4. I'm gonna say my 4. Okay. But a square here must be square. It means 4 squared equals to 16. So I can simply say 16. And then over my 2, just my 2. And then after that, we're going to say ln, and then write exactly what we have, which is this one. Square root of tan square 3x for now. And then we minus, okay? We minus a. What is a? A, 4 square equal to 9. 16, my apology. And then we plus f of x. What is f of x? Tan 3x. plus c. But look, because you don't have a limit. But remember, when you finish this, you must divide, even though it's not in the form, you must divide by this number which is in here. See this number here? So for this case, it's 3. So now what you're going to do, you're going to take this 3 because you want to, okay, look, you got the first group, all of this over 2, the second go with it. So I'm going to multiply this 3 here and 3 there. So it's going to give us 6, 6. So all this stuff is going to be over 6 once, so I don't have to write like this. So I can simply erase and then say over 6. All these 2 over 6. So I'm going to write one line here, one line, and then over 6. So for that case, for the first question, we're done with it. Now let me go for the second question. So second question is actually more easy. Way easy. So second question, it's kind of tricky to a lot of people, some people. Because, you know, if you don't know the approach of the question, it gets challenging, but it's very easy actually. So what I'm going to do, me personally, I'm going to differentiate the, I'm going to do the completing the square. How I'm going to complete this square? This is going to be x squared plus 4x plus 20. So if I complete the square that one, I got a problem with my pen is not. So this is going to be x plus 2 square plus 16. You can complete slowly. I believe you know how to complete the square. So for that case, then this is going to be integral. I'm going to place that one over, and there's going to be x plus 2, and then plus 16. 16 is like a 4 square dx. So then this is the tan inverse of a trig. Tan inverse of trig means it's going to be 1 over a. What is a? A is this number here, which is going to be 4. In this number here, 4. And then tan inverse, or you can say arctan or tan. Or you can say arctan if you want, or you can say tan inverse, whatever you think is going to be easy for you to say. And then we take this one with no square, x plus 2, over this number, which is 4. And then we plus constant because we don't have no limit. So we're done with the question number 2. We go to question number 3. Question number 3. Okay, this one we're done already. Okay, question number 3 is this is extremely easy. So I want to let the denominator let n letter. My pen, I finished my poem. N letter. Let's say Mntwana m equal to 1 plus cosh. So I'm going to differentiate. When you differentiate m, you get dm, and then you differentiate 1, you get 0. Differentiate cosh, you get sinh x dx. Oh, my pen, I finished my apology. Let's see what plans we can make. Okay, I got it something. Okay, so sinh dx. So sinh dx is this one right here. So I'm going to place sinh dx with dm. So I'm going to say integral dm 1 over, remember we let it equal to m, so this is going to be m. But this is equal to 1 equal to ln of the absolute of whatever you have here, which is m. With plus constant. So this is going to be ln, or m we know. What is the value of m? M equal to 1 plus cosh, because we did let here. 1 plus cosh of x. And then we plus constant because we don't have no limit. Now we're going to go, let's go to question number 4. Question number 4, which is the last question, is actually more easy. Oh, we done all the questions? I think we finished. I finished this. Which other question I haven't done? Let me see. My apologies. I think maybe I erased something by mistake. Sorry, let me check, right? I felt like maybe I erased the question unintentionally. Oh, maybe we finished. Just a second, right? I want to check if I did finish all the questions. I think I finished. I think so. Because this one I did this one also, and then I did this one. Yeah, there were only 3 questions if I'm not mistaken. Hey, look, if it's time, make sure to subscribe to this video, share this channel to a lot of people so I can continue to make a video. And please, let me know what type of video you want me to do it. Like I say, I'm an original black man. I'm a caveman. Okay? So hey, share this with a lot of people, man. Thanks a lot for your time. Follow me on Instagram, Mntwana_Wabantu. Thanks, peace, and I'm gonna see you soon. Peace, and I'm out. See you. Peace.